Welcome to our session. In this Converge event, we're going to explore the power of Citrix Unified Communication SDK. My name is James Su. I'm a product manager at Citrix, focusing on the unified communication ecosystem and also the multimedia redirection solutions inside the HDX product. Today, I have our lead developer for our Unified Communication SDK, Hailan Lee, with us. Hailan, would you like to introduce yourself?
Yes, hi. My name is Hailan Lee. I'm the software developer from Citrix HDX team. I've been working on multimedia redirection about 7 years.
Thank you. So let's dive into it.
All right.
All right, so the agenda today, we're going to cover the little bit of overview of the current challenges of real-time communication software in the virtualized environment. And also what will happen, what problem does the Citrix Unified Communication SDK can solve, right? And then afterwards, I'm going to hand it over to Helen, and she's going to talk about how does the SDK work. And lastly, most important information we want you to take away is how can you access this private SDK. Right. So to start with, the challenge on the real-time communication software in a virtual desktop environment is something that we are seeing every day now. Especially during the pandemic, we're seeing a lot of customers is trying to deliver a real-time communication application through a virtual desktop environment. So if you look at our traditional desktop, virtual desktop running inside a Citrix environment is breaking down into two components. One is the virtual desktop delivery agent, and then there's the client side, which is what we call the Citrix Workspace app. It's basically the client software that connects your end user to the virtual desktop. Now, in between them, there's the transport that we designed something called HDX, High Definition User Experience Protocol, and allowing customer to deliver audio and microphone and speakers through that channel. And typically, it's writing through TCP or UDP, depends on the available stack that is a customer can provide. Now, in this network, especially from work from home scenario, it's very subjective to the latency and also packet loss or network jitter, and all the recording that the user is sending through their microphone or hearing from the speaker has to traverse through this network. And then it has to go through an extra step, which is going through a decoding and encoding process to allow the virtual delivery agent to pass the audio into the audio mixers that is in the operating system in the virtual desktop. And lastly, the unified communication software that running inside will have to actually pick up those voice and encode it again, and then forward it out to the unified communication services that is running in the backend. So with these extra steps, like encoding here, decoding again, and then re-encoding again, and then send it back out to UC, which adds a tremendous amount of latency. So in a scenario where you have high latency in the network or any of the resource constraint inside the virtual desktop, your user is starting here like choppy audio input and user might hear like robotic voice and things like that. So these challenges will always present in the non-optimized format, right? So what we're going to do today is we're going to introduce you a Unified Communication SDK, which is designed to help company who have unified communication software that is based on WebRTC standard. And we provide a very simple and easy process to get you onto the optimization track. Right. So the objective of this Unified Communication SDK is to help application that is developed based on WebRTC to be quickly optimized inside Citrix virtual desktop and app environment. Okay, and the idea here is that we will embed a WebRTC media engine on the client side, and then allow the application developer to communicate to our embedded WebRTC engine via a set of API. Okay. And so you can kind of remote control your entire media experience from the virtual desktop. And then the actual audio and video call will be directly executed on the client side instead of hairpinning it in the virtual desktop agent. The requirement of this is the Citrix Virtual Desktop Agent requires the 1912 or higher version, and then the Citrix Workspace app need to be 2009 or higher version, running Windows, Mac, or Linux. So that's the basic requirement. Obviously, the application required to use our SDK in order to communicate them. Okay. So here's a high-level diagram. Imagine that you have an application that's based out of a Electron, for example. Okay, and then the application runs inside the this virtual desktop environment. You with the Chrome engine, and then you have a WebRTC stack. So traditionally, that's where the media runs with this WebRTC stack. And in the optimized format, we provide you an SDK. So the application vendor basically just have to they still use their signaling, right? And then they will communicate to the WebRTC media engine on the client side instead of using the local WebRTC engine. So when they talk to our SDK, this SDK will send the command remotely to our media engine that's on the client side. And then all the stun turn call that you will execute is all on the client end as well. And then all the media call and the media webcam and also microphone and speaker will be decoded and coded directly inside the client. So none of these high resource intensive application or real-time application requires network traversal of the media data. So all the media is processed and decoded and coded locally inside the client. However, your application logic is still maintained running inside a virtual desktop. So this is very important, is that if you have an application that actually talk to other apps, right? So let's say, for example, your contact center applications that you're taking your phone number from from another app. So all those applications is going to be executed inside the virtual desktop. And then only when you click on the call button, then the media engine starts and then runs on the client side. So this way, your application logic maintain integration highly inside the virtual desktop, without you have to do manual copy and paste or things like that, which is potentially can also introduce some security concern as well. So by using this UC SDK, it will allow the application vendor to have a very high integration potential with other third party, and then still maintain a very high quality audio and video user experience on the end user perspective. So without further ado, we're gonna dive into quickly. Let me retake this one. So the value of this Unified Communication SDK is you'll be able to get a better audio video quality from the end user perspective. And then we leverage the resource on the client side, so we don't consume too much resource on the VDI, okay? And then lastly is that it enables the application to have a tighter integration with other third-party apps inside the virtual desktop environment without leaving the desktop environment, and which can potentially introduce security concern for some integration options. And lastly, it's very simple to integrate, and we're going to dive into how easy it is we can get your application from 0 to hero using this interesting SDK. Hailan.
All right. So how does it work? We will go over high-level overview of SDK and some of the important sample code. All right. So there are several steps we need to set up before we can start using SDK. For example, determine if CitrixWebRTC redirection is supported or not, and setting up the application window for video calls specifically, and redirecting SDK logs to application side, and subscribing to CWA session events, and etc. To determine if Citrix WebRTC redirection is supported or not for a particular session, vendor application needs to define a method that returns a promise string of a specific Citrix registry key value. SDK will call into this method whenever necessary to retrieve this dynamic registry key value. The value of true indicates redirection is supported, while the value of false indicates redirection is not supported. Vendor application can also use this same registry key value to toggle WebRTC SDK-based implementation versus native WebRTC API-based implementation. Applications with the video capability needs to define a method that returns a promise hexa string of application window that contains video element. SDK will use this window handle to calculate overlay video element position, Z order, and the clipping information. So as you can see here, get window handle as hex. This function needs to be implemented by vendor application on the global object, window object, and the SDK will call this method to retrieve the handle of application window. And that application window should contain the video elements it needs. SDK logs valuable information and errors to console by default. However, the vendor application can redirect log output to its own defined class. And the vendor logger class must define required method, log method with a certain signature. And then SDK call this log method to pass all the log details. We encourage vendors to generate log files based on this log method so that we can reference back for any triaging issues later on. So as you can see here, the vendor apps can call init log method and then pass their own logger instance. And from that moment, all the SDK logs will be redirected to the application side. And then application can redirect that into local file system, log files, or any way it prefers. Citrix workspace sessions change dynamically. User can connect, disconnect, log on, log off, or there could be some errors in between. Vendor applications can either define method on global window object with a specific name. For example, in here is the VM event callback, or it can invoke SDK method to register event callback. So in this case, the second method is set VM event callback, and then the parameter passed in here is actually a callback method. And from that point, any session-related events are going to be notified through this callback. As you can see here, the VDI client connected event indicates we are all set and ready to start WebRTC tasks. On the other hand, VDI client disconnected event indicates that redirection cannot continue. So in this case, application may consider taking some actions based on the reason code. For some of the reason code, application can fall back to native WebRTC implementation for smooth user experiences. So for example, in this case, if the reason code is failure, or reason code indicates that endpoint, the CWA endpoint does not support the redirection, then application can fall back to native WebRTC implementation. So this can happen smoothly, transparent to user being aware of. For successfully redirected session, vendor application can directly use client endpoint media devices, and the apps can call a method to enumerate available devices on the client endpoint. Then filter devices based on device type, and supported device types are audio input, audio output, and video input. So here's an example of how we can enumerate all the available devices on the endpoint. SDK enumerate device call is pretty much the same as standard Navigator Web API, as you can see from this sample code. So at this point, we are ready to perform any call-related tasks. The typical steps involved to set up the call are create a peer connection, and set up event callbacks for the peer connection. And then we need to create the media stream with certain constraints. And once media stream is created, we will add that media stream into peer connection object. After then, we will use create offer or create answer to generate SDP string, and then use that SDP to set up either local or remote descriptions based on the situation. After then, we will set up remote stream into connecting those into local endpoint devices. So creating a peer connection and setting up callbacks are nothing unusual here. It's pretty much very similar to native WebRTC API. However, there's one difference in here, is how we set up a DTLS. Note that this is an outside of WebRTC specification. So in this case, in order to enable DTLS, we are gonna use this enable DTLS SRTP property of peer connection configuration and set that to true, and then use that configuration to create the peer connection. So that's how we turn on the DTLS. When setting up audio-only call, constraint is pretty simple. All we need is to properly set input audio device ID. For example, which microphone to use. As you can see here, device ID here is, you need to use the input microphone device ID, which we retrieved earlier from enumerate device. Once create media, notice that this, sorry, I need to retake this slide, 19. All right, restarting. When setting up audio-only call, constraint is pretty simple. All we need is to properly set input audio device ID, for example, which microphone to use. So in this case, microphone device ID is set to device ID property of this constraint. Once we create the media stream with get user media, then we add a cloned copy to peer connection object. So it's very important. We need to add a clone copy into peer connection object. So for video calls, we need both audio and video constraints. Vendor applications can call get user media separately for audio and video with separate constraints, or can call once with combined audio video constraints. In video constraint, we need to indicate selected video input devices as source ID. Once we create the media stream, we can feed this stream to local self-preview video element by assigning stream to video element source object property. Notice here, preview video element needs to be mapped first by map video element function. And then again, we need to add a cloned stream to peer connection. So it's very important we call map video element for local preview video element, and then set source object of that preview video element with a stream that we created by using get user media above here. And then once we do that, we will add a cloned stream into local peer connection object. We are now ready to generate SDP by using create offer or create answer. With this SDP, we can either set local or remote SDP depending on the situation. So very important here, notice that when setting up SDP description, the SDP constraints should contain both audio and the video, even if application only cares about the audio. Right. So now we are ready to set up the remote stream. When the endpoint receives remote stream, this event is notified to application via peer connection callback method on add stream. For audio-only calls, audio element needs to be mapped first, then wire audio output device to audio element by sync ID property. After then, we wire remote audio stream to audio element via source object property. And then finally, based on the user preferences, we can enable or disable remote stream tracks. So if user setting is muted, then we probably set enable to false so that the call is muted. Right. So setting up the remote video stream is pretty similar to the audio call. First, we need to map video element by map video element method, and then wire audio output device to video element via sync ID. After then, wire remote video stream to video element via source object property. And then again, finally, based on the user preference, we can enable or disable remote stream tracks. So one very special case for the video call is there are times that we may need to show HTML overlay on top of video elements. Since the video is actually rendered on the client endpoint via overlay window, we need to know rectangle areas where SDK should draw video content. In other words, we need to know what area that we need to leave alone. We need so that overlay HTML overlay element can show up. Vendor applications can use add cliprect or remove cliprect to pass this information to SDK. So XY coordinate that's shown in here is, for example, in this HTML element, overlay element, left upper corner XY is relative to the application window. And when application no longer need HTML overlay, it can call remove cliprect to cancel out this special instruction. All right, so screen sharing is also supported via get display media. The function signature is the same as standard native web API. Once media stream is created from get display media, we can clone the stream to peer connection. So that's pretty much the steps involved for setting up the call. Some of the upcoming perks are the promise-based APIs. Current existing SDK mostly is defined based on the synchronous methods, but promise-based APIs are on the way. And WebRTC 1.0 support is also coming. For example, add track, remove track, add transceiver, remove transceiver, and those related features are coming. As well as unified semantics and the DTLS for peer connection configuration, and also for some of the other data paths while the call is active. Is data channel. Data channel is utilized to pass some of the auxiliary data information in addition to audio channel. So that's all from my side. I'm going to hand it over to James.
All right, thank you. So before we wrap it up, the most important thing is that let's talk about how can we access this SDK. Today, this SDK is still a private SDK. We require you to sign up in Citrix Ready program and join the Unified Communication SDK program. In this program, it will grant you access to the Unified Communication SDK. So it's important that you visit this page if you after you looked at our session content and you're interested in leveraging this SDK to optimize your application. Please contact us at the Citrix Ready, and we'll be able to provide you access with this SDK. All right. Thank you, Hailan, and thank you for listening.
Thank you.